Happy Monday, science students. How's everybody doing? Hanging in there? Hopefully everybody's keeping healthy and safe and has a good way to pass the time. Talk to people if you need to. Check in with your friends, your teachers, whoever. We're all here and have to watch out for each other. All right, everybody ready? We don't have a lot to do today at all, so let's get started and get this out of the way. I love it when the video includes the clicking sound of me continuously and fruitlessly trying to get my tablet to pause recording. That's always fun. Anyway, what do you think about this? If this happened and the forest burned down, would it be gone forever? Could it ever come back? And I mean as a natural process, not that people moved in and developed things or planted trees or something. What would happen here? What would take place if the lightning actually struck that tree? What would happen to the ecosystem? And first of all, can we just acknowledge how cool looking this lightning is? How weird is that? Just little squiggly lines, not the typical bolt that we usually say. There must be something that happens when I'm asking this question, right? So let's explore. Today we're looking at the idea of ecological succession. This is when an ecosystem changes until it establishes a stable balance. In the example from a minute ago, a forest fire wouldn't be the end of the story. As the original Jurassic Park taught us, life will find a way. If something happened to the area in this picture, a fire, a flood, or volcanic eruption, or it got trampled by a giant radioactive lizard, the ecosystem would come back eventually. It might take 100 years or 1,000 years, but nature would gradually reset, and as Dr. Ian Malcolm said,
life finds a way.
I just recorded 47 seconds of a slide and realized I turned my microphone off for the video, so good job, Dr. Malcolm. Life will find a way. Anyway, change in ecosystem doesn't happen all at once. Just like the scene outside doesn't suddenly change from winter to spring overnight, succession shows the same kind of concept, just on a bigger scale and over a longer period of time. So notice in this picture how at first some soil will need to appear, either moved by wind or formed when rocks break down. Once there's soil, you can get things like moss and small grasses or weeds. Then come smaller plants, followed by bushes, small trees, eventually bigger trees, things like that. The first plants to appear in an area as an ecosystem resets are called pioneer organisms. Think of where you hear that word though, pioneer. These are like the settlers moving to a new area back in 1700s, 1800s, explorers. However long this process takes, with life getting more and more advanced, more widespread and larger over time, eventually the environment will return to stability where it is what it's going to be. This stage is called a climax community, since it's like the end of a story. So we start small, and eventually it gets to the point where stuff is changing, things are happening every day, going on, but you're pretty much set in what you're going to be. The forest is where it's going to be, basically finally. If you've ever seen old maps in history class or elsewhere, it's not uncommon for them to look pretty different from what we know. And not just because there's lots of buildings now and things like that, that's obvious. A lot of these maps will say things like they have one road on them. A lot of it's just kind of open land. It'll be like so-and-so's property and things that we would never recognize nowadays because it's changed so much. Maybe you've seen something like what's going on in these pictures if you spend any time in nature. This small pond can get filled up with leaves and other debris pretty quickly, causing it to disappear. Now when I say quickly, this might take a few years, but that is pretty quick in the grand scheme of things. Suddenly it's flat ground. You'd never know that there used to be water there. This is on a very small scale, but succession is just this same kind of thing happening over a much longer period of time and a much larger scale. As for how this actually happens, let's take a look. We have two examples here of ecosystems starting over. The top of your screen shows changes happening over time from left to right, while the bottom has pictures numbered in two rows, left to right and then top to bottom. The first example on the top of this type of succession is called primary succession. Primary like a first thing happening. And we see an area where there was no life before, or where everything that was around was completely destroyed. So it could be a rocky area where nothing grows, or maybe a volcano destroyed a forest and left a new layer of rock behind, if you remember that kind of thing from earth science. You can't get plants growing without soil, so there's nothing alive here at this point, yet. But over time, rain and wind can wear down the rock or deposit dirt to start the foundation of new soil. And then that same wind and animals may carry seeds or spores into the area. Now you'll start to see moss and grass, and this spreads over time, allowing larger plants to eventually move in. The key idea here is that this is not a fast process whatsoever. This takes time, especially when you're starting from scratch. The bottom pictures show secondary succession. In this situation, there was a stable ecosystem previously, but something happened to it. So in these pictures, a forest is destroyed by a fire and all the plants die. But the soil remains. That means there's still nutrients in the soil. All the plant material that died is now in the soil. but nature has something to work with, so this is not a total rebuild. The foundation is there already, and it's just a matter of new seeds being carried by wind or water animals, as we saw in the example above. And if the soil already contains roots or seeds from the original forest, this could be an even quicker process. So primary succession may take hundreds of years because it's starting from bare bedrock, but you could see some real strong secondary succession in the span of a few decades. I'm going to put a link to another video below this one in OneNote in case you want a little more visualization. It's probably only about 2.5 minutes, but it was too big to actually post in here. And it's got a lot of these same pictures actually, which is kind of weird because I didn't plan it that way. But it does a really good job of just kind of explaining how this thing works. And again, like I showed in the picture in the last slide with the little pond, you may see this even in your backyard somewhere. If you just see like little holes in the ground or something, they can get filled in really easily, and you may just see small changes like that happen over time. Maybe you had a garden at one point and you stopped tending to it, so now it's really overgrown. And you see very quickly how nature changes when left to itself. Okay, that's all I have for today. So go right now and do the form below, and then complete the succession worksheet in the OneNote file labeled Monday at some point. I know I said this the other day, but this is really a weird time. I know we're all doing what we can, so trying to be pretty fluid with deadlines. I'm going to go back and check last week's work today. So if you didn't finish anything for any reason, let me know, and I can open it back up for you if I need to, or check any work you may have posted somewhere. But otherwise, I'm supposed to start putting grades in, so make sure you get to everything. Thanks again to everyone who has sent me pictures of labs or told me to check OneNote files. You still have a week or so to get things in, but please make sure you keep on top of everything so you're not missing anything and know you can get everything done. Like I said at the beginning before, just check in with me, with each other, look out for each other as best you can, and stay safe. Reach out with any questions. I'll talk to you tomorrow.